Hi viewers, welcome to demonstration. Today we are going to see about standalone solar PV motor for water pump application. This is a model we are developed for standalone solar PV induction motor for water pumping application. This model consists of two parts. One is standalone PV inverter and then we have induction motor load. So this induction motor load going to be act as a water pump. So that means the speed of the induction machine going to be squared by using this block and then is multiplied with the gain and then is given to the mechanical torque input for the induction machine. Then this induction machine going to act as a water pump. That means it going to act as a centrifugal pump concept. And then here we have standalone PV inverter. When go inside that, we have solar PV array, boost converter with MPPT control, and then grid inverter with the harmonic filters and the transformer. This inverter going to be controlled by means of this inverter control. So next we have to see about PV array. Here you can see that this is a PV array, single panel having a power rating of 414 watts, and then the open circuit voltage here is 85.3 volt, and then voltage at maximum power point is 72.9, and short circuit current is 6.09 amps, and current at maximum power point is 5.69. Here we are using 7 string in series. So that means 72.9 into 7. That means 72.9 into 7. The voltage around is 510 volt. And then we have to calculate number of barrel string here. For example, I am going to consider 5. That means the panel PV array here is designed for 5 kilowatt. So I'm going to use 5 divided by 7 into single panel voltage, and then the current maximum power point is 5.69. Here you can see that here you are considered 2 parallel string. That means 7 into 72.9 into 5.69 into 2. Here we are considered the power rating of the panel is 5.8 kilowatt. The rating of the panel here is 5.8 kilowatt. And then here we are using boost converter. Here we are going to convert this boost converter input. That means 510 volt to here we have to convert to 1000 volt. For that, here we have the boost converter with the MPPT control. Here we are measuring the PV voltage and the current, and then it's going to be processed via MPPT. This MPPT here we are using is incremental conductance MPP. That means here we have to calculate dI by dV. Here you have to calculate I by V, and then you have to add here both will valid here and then process via integral controller, and then it will be generated duty cycle, change in duty cycle. This change in duty cycle will be add up with the initial duty cycle, and then it will finally provide the actual duty cycle. This duty cycle will be processed via PWM generator. This PWM generator generate the pulse called the boost converter. You have to boost the voltage from 500 to 1000 volt, and then this output of this boost converter is going to be connected with the neutral point clamped inverter and the harmonic filter and transformer. This neutral point clamp converter will be controlled by means of this inverter control. Inside this inverter control, here we are going to measure the PV measurement. Then you got to measure the PV detail like PV power and current. And then here we have PV. Here you have to measure PV voltage and current. And here we have PV power. This PV power going to convert it into reference speed by using this gain value. So this gain value is for converting PV power into reference speed. And then here we are measuring the speed of the induction machine. So this reference speed is compared with the actual speed of the induction machine. So here we are getting the error speed. So the error speed when we process via PID controller. This PID controller will be generate the frequency, that means operating frequency for that inverter, and to control the speed of the induction machine. Here we are applying V per F controller. So based upon that frequency, here we will generate the 3-phase sinusoidal waveform. It will be act as a V bar of control concept. Based upon frequency, we are generating the 3-phase sinusoidal waveform. That frequency of the 3-phase sinusoidal waveform, the voltage amplitude going to be controlled by means of the output from the PID controller. Then the 3-phase sinusoidal waveform going to be processed via modulating block. This modulating block will be generate the controlled voltage for the neutral point clamped inverter. The control voltage from that inverter control is going to control this neutral point converter not to supply the power to the induction machine. Here we are going to test the model with the fixed irradiation as well as a change in irradiation condition. Now initially I am going to make that irradiation equal to 1000 watts from British current and 25 degrees Celsius, and then check the results of the system. That means here you have to check the solar PV power, induction motor power, and then speed of the machine, electromagnetic torque of the machine, and then speed error and frequency of operation. Now I will be simulate the model and then you will check the results of the system. So now the systems operate at 1000 watts per meter square and at 25 degrees Celsius. Here we are getting power is around, here you can see that around we are getting 5.5 kilowatt, and then induction motor power is 19 around 4 kilowatt, right? 4.5 kilowatt is the speed of the induction machine. According with the speed and power from the solar PV, the speed reference command is given to that inverter control. Because of that, here you can see that the frequency of operation is around 50 Hz. Because of that, the speed of the induction machine is maintained around 1500 RPM. Here is the electromagnetic torque of the induction machine for the particular irradiation temperature condition. So next I want to operate the same system with the 800 watts per meter square and then check the results. So I'm going to simulate this same model with the 800 watts per meter square at 25 degrees Celsius. So now because of that means reduction in irradiation, definitely the power extraction from the solar PV also going to be reduced. Here you can see that we are getting maximum power around the 4 kilowatt, and then induction machine is operated around the 2.7 kilowatt. This is the speed of the induction machine is maintained around 1200, and that means try to reach the 1200 RPM, and then this is the electromagnetic torque of the induction machine. And then here you can see that this is speed error try to reach to 0, and then frequency of operation of the induction machine is around this 40 Hz. Next I'm going to test the same system with the change in irradiation condition. For that I'm going to connect this step input, and then initially I'm going to operate the induction machine at 1000 watts per meter square. After 3 seconds I'm going to change the irradiation from 1000 to 800 watts per meter square, and we have to check the results of the solar PV system induction machine. Now I'm going to simulate the model. Initially the power of the induction, that means irradiation of the solar PV system, is 1000 watts per meter square. Because of that we are getting power around, here you can see the power of the solar PV and the power of the induction machine. Because of that we are getting solar power around 5.5 kilowatt, then 5.7 kilowatt, and then the power of the induction machine is around 4.2 kilowatt. Here you can see this speed of the machine is try to maintain at 1500 RPM, and then this electromagnetic torque of the induction machine, and then here you can see that this is a speed error, and then this frequency of inverter, operating frequency of the inverter. After 3 seconds the irradiation change from 1000 watts per meter square to 800, and then we will check the results. Now we can see that because of reduction in the irradiation, right, the PV power, right, is maintained at around 4.5 kilowatt, and then the power of the induction motor is maintained around 3 kilowatt. Here you can see that the speed of the induction machine is maintained at 1200 RPM, and then this electromagnetic torque of the machine, and here you can see the speed error, right, speed error is almost 0, and then the frequency of operation of induction machine is around 42 Hz. So this is the operation of standalone solar PV system with induction motor for water pumping application. Thanks for watching our videos. Kindly subscribe to the channel and also click bell icon for more notification about upcoming videos. Thank you so much. Bye bye.